We will continue our discussion in Chapter 8 by talking about the gas laws, and we will start by discussing Boyle's law. Boyle's law relates the volume of a gas to its pressure, and it goes something like this. The pressure of an amount of gas that is fixed, it doesn't change, at a constant temperature, so the temperature doesn't change either, is inversely proportional to the volume of the gas. Now we know this, right? Because we just talked about how when we compress a cylinder, right? So if I have a gas in a cylinder and I compress the piston, the pressure goes up. The volume goes down, but the pressure is going up because now I have smaller area. Then I'm concentrating the gas. And so the volume and the pressure are inversely related to each other. So this is kind of the relationship mathematically. Volume is related to 1 over pressure. This means inversely related, 1 over pressure. So whatever the variable is, in this case is pressure, this is inversely related. Now, if I want to express this a little easier, I can express Boyle's law in terms of the product of the volume and the pressure. So the product of volume times pressure is constant. If this doesn't change, right, if I'm multiplying two numbers, but that product is not changing, if I decrease this, it's going to increase that to make up for the decrease and keep this number constant. The volume, as we said, is inversely proportional to its pressure. Note that the total pressure that is exerted on the gas is the sum of the atmospheric pressure and the difference in mercury height, right? So it is given as the sum of this, if this is the atmospheric pressure right here, and then if this is my 760 millimeters of mercury, which is the atmospheric pressure, and that is, right, the pressure that is exerted from the gas, and so it's going to be the difference in the mercury heights. So that minus this is going to give me, so the difference in mercury heights is going to give me the total pressure. Now, if I were to plot the volume of a gas as a function of pressure, so V versus P, not the inverse, but the volume versus the pressure, you can see that the pressure decreases with volume, right? So if this is my pressure, that's my volume. You can see that if either direction, so if the volume, right, is increasing, so here I have a high volume, but I have very low pressure. And here, my volume decreases quite a bit, while my pressure now increases. So you can see how it's a downward curve because they are inversely related to each other. But if I then plot the volume as a function of 1 over pressure, 1 divided by pressure, you will see that it is a line that it increases linearly with volume. So typically if I just do volume versus pressure, that's going to decrease. But if I do volume versus 1 over pressure, it's going to increase linearly. And if I basically just by looking at the forms of this graph, I can then figure out that volume and pressure are inversely related to each other. Here's a sample problem for you to try. If I have a skin diver that takes a breath at a surface that fills his lungs with this much volume, so 5.82 liters of air, what volume will the air in his lungs occupy when he dives to a depth where the pressure is 1.92 atmosphere? Assume obviously constant temperature and that the pressure at the surface is 1 atmosphere. That is my atmospheric pressure. So at the surface where he takes his breath, the initial breath is 5.82 liters and 1 atmosphere. And then what happens to that volume when the pressure increases? Here is the formula that you should use. So the pressure of the initial pressure, which is atmospheric pressure, and the initial volume. This is pressure at time 2. So at the depth that he is diving is 1.92 atmosphere. What is V2? So solve for V2, which is the volume at the depth that he dives.